learn, excel, and achieve. Today we'll be looking at linear motion under physics. We want to study the topic linear motion. Now, what is linear motion? Linear motion is simply a motion in a straight line. Now, we also have motion under gravity, but motion under gravity has to do with a motion that gravity influences, meaning it's either going up or it's coming down. Is that an object or a body or whatever is going up or coming down? But when it comes to linear motion, it's moving in a straight line, either forward or backward. Either forward or backward. So linear motion is simply a motion in a straight line. A motion in a straight line. In a straight line, simply. Now, straight to business, we have some equations of motion that we use to solve problems under linear motion. Let's go ahead to look at it. But before we go to that part, we're going to look at the quantities we use in linear motion. Now, we have acceleration. We have acceleration A, all right, which is measured in meter per second squared. We have velocity, not just velocity, we have our final velocity V, measured in meter per second, and we have our initial velocity U, also measured in meter per second. We have our distance, S, measured in meter, and then we have our time T, measured in seconds. So these are the main quantities we deal with. We deal with acceleration, final velocity V, initial velocity, distance, and time. Now, let's go ahead and derive those equations that we're going to use to solve problems under linear motion. Now, the first one is we're going to derive the first equation of motion, and it comes from, now, acceleration A is equal to change in velocity over time. All right, change in velocity over time. Now, before a car starts moving, it has an initial velocity. And then when it finally moves and gets to its final destination, it now has a final velocity. So if you are saying change in velocity, you are simply saying what's the difference between the final velocity and the initial velocity. Initial means the beginning. Final means, of course, the end. So acceleration A is equal to change in velocity. That's going to be V minus U over T. All right? V minus U over T. Now let's cross multiply. Now when we cross multiply, we're going to have V minus U is equal to AT. All right? Just cross multiply. You have V minus U is equal to AT. Now, of course, what do you do? Take this minus U here. It becomes what? V is equal to AT plus U. Taking this here, all right, when you take this here, it becomes plus U. Now, of course, V is also, I can also write this as V is equal to U plus AT. And this gives me the first equation of motion. The first equation of motion. All right? So this gives me the first equation of motion. V is equal to U plus AT. This is how it was derived. Now, let's go to the next one. But before we go to the next one, I want to remind you that distance S is equal to average velocity times time. That's multiplied by time. Distance S is average velocity times time. Now, when I say average, what am I talking about? I mean the mean. So we only have two velocities, final velocity and initial velocity. If I'm looking for the average, it means that I'm saying add the two velocities divided by 2 because we just have two velocities. So in form of equation, it becomes S is equal to average velocity. That's going to be V plus U over 2. So this is average times time. All right. Now, take note. All right. Take note. This is the second equation of motion. All right. Take note of this. This is very, very important. All right. Take note of that. So from this equation, that distance is average velocity times or multiplied by time. Now, we're going to recall from equation 1, which is this equation 1, that V is equal to U plus AT. So we're going to substitute equation 1 into equation 2. Meaning, we're going to substitute V is equal to U plus AT into equation 2. So anywhere we see V, we substitute it with U plus AT. So it becomes S is equal to U plus AT plus U divided by 2 multiplied by time. Now, let's go on. So it becomes S is equal to, of course, U plus U gives us what? 2U plus AT over 2 multiplied by time. Now, this time is going to open this. It's going to multiply all this. So it becomes S is equal to T multiplies this becomes 2UT plus T multiplies this becomes AT squared, all divided by 2. Now, according to the law of fraction, if I have A plus B over C, I can also split it as A over C plus B over C, because this C divides A and also divides B. So I can apply that fraction of rule of fraction here, and it becomes S is equal to 2UT over 2 plus AT squared over 2. And then, of course, you notice that 2 takes away 2 here. So S is equal to UT. Let's write this better. UT plus. Now, AT squared divided by 2 can also be written as half AT squared. And this gives us the third equation of motion. This gives us the third equation of motion. All right? This gives us the third equation of motion. So take note of that. Now let's continue. All right? Let's continue from here, because I think we still have small space here. Let's continue from here. Hope you've written this. Take note of that. Very, very important. All right? So let's continue from here. Now, we're going to recall from equation 2. From equation 2, we know that S is equal to V plus U over 2 multiplied by T. All right? Now, we're going to make T the subject of formula from equation 1. Now, where's equation 1? This is equation 1. V is equal to U plus AT, right? So we're going to make T the subject of formula, all right? So what do? We're going to make T the subject of formula. What do we do? We make T the subject, we take U to this side, right? So we have from equation 1 is actually V is equal to U plus AT. This is actually equation 1. So we want to make this T the subject of formula. So we take this here, all right? It becomes V minus U is equal to AT. Now, if you have V minus U is equal to AT, V is minus U is equal to AT. AT is also equal to V minus U. So you can still write it as AT is equal to V minus U. Now, finally, to make T the subject of formula, you divide both sides by A. So if you divide both sides by A, you have T is equal to V minus U over A. So this is T is equal to V minus U over A. Now, we're going to substitute T is equal to V minus U over A into equation 2, which is this. All right? which is this. So we're going to substitute t is equal to v minus u over a into equation 2. So anywhere we see t, we're going to put v minus u over a. Do you understand? Do you understand? All right. So let's continue. I can take this off. Let's continue from here. Let's continue from here. So we can use here, finish, then we come here. Now, so it becomes S is equal to what? V plus U over 2 multiplied by, now this is T, right? And the whole of T in this case is what? V minus U over A. All right? So it becomes S is equal to what? You multiply this, right? So V times V gives us what? V squared. V times minus U gives us minus what? UV. U times V gives us what? Plus UV. U times minus U gives us what? Minus U squared. All divided by 2 multiplied by A, 2A. Alright? So it becomes what? S is equal to, now of course you know minus UV takes away plus UV. So we are going to be left with what? V squared minus U squared over 2A. Now we cross multiply, right? Let's cross multiply, right? Hope you know this over 1. So cross multiply becomes what? V squared minus U squared is equal to what? 2AS. Do you understand? Are you sure you understand? Are you sure? All right. So now, let's take minus U squared to this side. It becomes V squared is equal to what? 2AS plus U squared. Now, you can also write this as V squared is equal to U squared plus 2AS. And then this now gives us what? The fourth equation of motion. All right? The fourth equation of motion. So this is the first equation of motion, second equation of motion, third equation of motion, and then fourth equation of motion. So we use these equations to solve problems under linear motion. We use these equations to solve problems under linear motion. Now, what we're going to be doing now, we're going to be exploring different problems on linear motion. Let's see how we can use these equations that we've derived to solve problems. Now, before we go ahead to solve more questions or problems on linear motion, I want you to take note of this. Now, when you have a problem that says a body starts from rest, all right? When I say a body starts from rest, it means that, take note of this, please. It means that the initial velocity u is equal to 0. All right? So this is the first thing you have to take note of. Take note. All right? Now, for the second one, when they say a body comes to rest, a body comes to rest, it means that the final velocity of that body, the final velocity v is equal to 0. So there are two cases. When the body starts from rest, its initial velocity is what? 0. When the body comes to rest, its initial velocity is what? Its final velocity is what? 0. Two different words, right? Please understand them. Very, very important. So now let's go ahead to solve the first problem. Let's go ahead to solve the first problem. It says a car, that's the one, a car accelerates uniformly from rest at 5 meters per second squared. Determine its speed after 10 seconds. After 10 seconds. Now, let's write the equations of motion here again because we'll need them. Now, the first one is V is equal to what? U plus what? AT, right? Equation 1, right? The second one was what? S is equal to what? V plus U over 2 multiplied by what? T. This is what? Second one, right? All right, the third one is what? S is equal to what? UT plus half AT squared. That's equation what? 3, right? And then we have V squared is equal to what? U squared plus 2AS, right? Fourth one. Now, let's come back to the question. It says a car accelerates uniformly from rest. This is an information, meaning that the initial velocity is 0. All right? It means that the initial velocity is what? 0. Now, a car accelerates uniformly from rest at 5 meters per second squared. Now, that 5 meters per second squared is the what? Acceleration, because it is measured in what? Meter per second squared. Determine its speed. Speed, that's velocity, right? So now, determine its speed. That's the final velocity. They are asking you to determine its speed, which will be its final velocity after it moves for what? 10 seconds. Now, that's why when you're solving any physics problem, or any problem, write down the parameters that are given to you. When you write down the parameters that are given to you, you'll be able to check some things out, and you'll be able to remember a formula and solve it. All right, or know the right formula to use to solve it. So now, we have U, we have A, we have V, we have T. Which of these equations of motion is perfect to use to find our answer? The first equation of motion, right? So using what? V is equal to U plus AT, because we can find U, A, V, and T. So it becomes what? V is what? We don't know, right? Is equal to U is 0 plus AT. That's what? 5 multiplied by what? By 10. So that's equal to V is equal to what? 0 plus 5 times 10, 50. 0 plus 50, of course, gives us what? 50. That's 50 meters per second. So its speed after 10 seconds will be what? 50 meters per second. Do you understand? Now let's go ahead and solve more problems on this. So let's look at this question. It says a lorry moving with a velocity of 2.5 meters per second. All right, accelerate at 10 meters per second squared for 4 seconds. Calculate the distance covered. A lorry moving with a velocity of 2.5 meters per second accelerates a body moving with a velocity. This velocity, is it the final or the initial velocity? A body moving with a velocity, it has the starting velocity, that's initial. So meaning that U in this case is equal to what? 2.5 meters per second. All right, accelerate at 10 meters per second squared, 10 meters per second squared for 4 seconds. Calculate the what? The distance covered. All right, now you have your UATS. Which of these equations of motion has complete of this for us to use to find our distance covered S? The third equation of motion, right? So using what? S is equal to what? UT plus half AT squared. It becomes what? S is equal to U is what? 2.5 multiplied by T is what? 4 plus half multiplied by what? A, which is what? 10 multiplied by T squared, which is 4 squared. Now we know that 2 can go here 1, 2 can go here what? 5. So this 2.5 times 4 gives us what? 10. All right, plus now 4 squared is 16. 16 times 5, that's 80. So S is equal to 10 plus 80, that gives us 90 meters. So the distance covered is what? 90 meters. Now, make sure you like this video, share this video, and hit the subscribe button. And after you hit the subscribe button, also hit the notification button. And if you have any question for me, keep it in the comment section, and I'll do well to give you an answer. And also, make sure you follow up more videos on linear motion, because I'll be uploading more videos on linear motion. Learn, excel, achieve.